Hello students, hope you are doing well. So today in this lecture we are going to discuss about IUPAC nomenclature of organic compounds. So organic compounds, if we talk about, these are compounds majorly made from carbon and hydrogen, and these can be derivatives of other elements like nitrogen, sulfur, oxygen, etc. So when we talk about IUPAC you have done like you know the full form, that is International Union of Pure and Applied Chemistry. So this association, or you can say this is responsible for any kind of ruling that we have in chemistry. So even in your lower classes you have studied about chemical formulas, that is again given by IUPAC. Similarly, in organic compounds the code nomenclature is given by IUPAC itself. So when we have to name an organic compound, we need to understand the name, like how it is written and what are the parts of those organic compound. So when we write an organic compound, the major thing that we have is the word root. I'll explain one by one. And then just like if we have a starting of any kind of name, that is something called as prefix. Similarly, we have suffix. So these are the three, you can say, parts of the like IUPAC name specifically for organic compounds. So prefix, word root, and suffix. So I'll start from the word root. So when we talk about word root is nothing but it indicates number of carbon atoms in the long chain. So just like if we have carbon covalently bonded with each other, so we always need to find the maximum chain that we need to have in the main as a main parent chain also we call. So how many carbon atoms are there in that main parent chain? So that is nothing but what we call as a word root. So if I have, let's say, one carbon chain, so we use the word root, that is meth. For two carbon chain we use the word root eth. Three carbon, prop. 4 carbon, but. 5 carbon, pent. 6 carbon, hex. 7 carbon, hept. 8 carbon, oct. 9 carbon, non. 10 carbon, dec. So even after that also we have like for 11 it will be undec, dodec, tridec, tetradec, like that. So that series will start. So we'll do it in this lecture only till 10 carbon. So this is our word root. So just like any name has prefix, so in prefix we have two types of prefix. One is called as secondary prefix, another is primary. Similarly, in suffix we have primary suffix and secondary. So I'm writing a short form. 2 degree over here stands for secondary and 1 degree stand for primary. Then similarly we have primary suffix, and this will be termed as primary suffix, and this will be termed as secondary suffix. So now what are these? So if we have something called as alkyl groups, I'll explain in a minute, or any other substituents. So we'll discuss about substituents also later. So primary prefix over here will be specifically just one example I'm taking over here, that is cyclo. So there's a sequence, like if you have a ring structure, so definitely you have any group attached to the ring, so that will be written first, then comes the cyclo, then comes the word root, and then suffix if we talk about. So I'm just giving an overview over here. Best you will be understanding by taking examples. So if we talk about primary suffix over here, primary suffix indicate like whether we have carbon carbon single bond, so we write ane. Then carbon carbon double bond, whether it's ene. So if you have an organic compound where is a double covalent bond, so definitely the suffix will end with ene, ene. All single covalent bonds, ane, that is uh, like alkanes we call them. So they belong to the general family alkanes. So ENE stand for double bond, triple bond, YNE. So this indicates like we already have like this before starting this nomenclature part. It's being taught that what are alkanes, alkenes, alkynes. So alkanes are carbon carbon single bond, alkenes are carbon carbon double bond, alkynes are carbon carbon triple bond. So general formula also has been discussed previously. So if we talk about secondary suffix, so what is this? This is specifically the suffix of functional groups. So functional groups are different. These are you can say different class or for organic compounds. So majorly these you can say groups, or you can say, or we can define it. So functional group can be an atom or group of atoms responsible for the chemical properties of an organic compound. So if we talk about let's say, like this is introduction, like we have introduced, so this is a sequence. Prefix comes first, then word root, then suffix, right? So suffix has two part, primary and secondary. Prefix has secondary and primary. So if you want to memorize, like if we talk about this primary, like if we check this part, this one. So if we talk about this primary, this is always towards the word root. This is how we can memorize it, because sometimes for students it's very confusing that whether secondary comes first or primary comes first, or like the sequence I'm talking about. So secondaries are always basically at the terminals, but primary is always going to be towards the word root. This is how you can remember it. Then coming to main part, after that, what are alkyl groups? So we know about alkenes. Alkenes are carbon-carbon single bond. They have a general formula CnH2n plus 2n is the number of carbon atom over here. So if you take like ane as a suffix, so subtract that, add another suffix that is -il, even we have to remove hydrogen from it. So this is going to become alkyl. So let's take an example. If we have methane, meth stand for what? Now meth is basically what? This is the word root. Ane stand for primary suffix. This is how we segregate, like this is for your understanding of the IUPAC name, like how it is written. So word root comes first, suffix comes later, then prefix. There is no prefix over here, so we are not going to write. We are going to start the name from the word root. So now over here, so we have to remove one hydrogen, and then we have to add the suffix il. So this is CH3. So I'm showing a continuous bond over here. So this indicates what? This alkyl group is never going to exist on its own. It's always a part of the main parent chain. Now it's up to us, like when we are giving a name, giving a proper name based on the set of rules to the to that particular structure, like what name it should be there. So we decide, which carbon can act as an alkyl, but it is always a part of the main parent chain. So it's a branch which is acting on the main parent chain. So this will become methyl. Similarly, if we have a continuous chain of 2 that is attached to the main parent chain, that will become ethyl, propyl, butyl, like that. So we'll take one simple example. Now this is a very simple example that we are taking right now. So if we talk about this structure, so first thing is that every carbon can form maximum 4 covalent bonds. So this this is a condensed formula. This is not a structural formula. We can make structural formula also. This carbon is covalently bonded to this carbon only, like one carbon atom. So how many covalency of carbon is 4? That means it can form 4 covalent bonds. So 3 hydrogens we have to add over here. Similarly, this Carbon will have only one hydrogen because already it is forming three covalent bonds over here. And the terminal carbon, like this, the ending carbon, we call them as terminal carbon, again will have three hydrogen. Even this is terminal carbon. So this is the lines that I'm drawing, everybody know that is the covalent bond. I can shrink it, that is like this. So this is the condensed formula. In condensed formula, we don't show the bonds between carbon and hydrogen. We only try to show the bonds between carbon and carbon, right? And the carbon and hydrogen bonds are shrinked. That's why the condensed formula. Now in this, if we want to write the IUPAC name, so if we can have multiple options. We can start the numbering from this carbon 1, 2, 3 straight. You can go. You can start from left hand side, or you can start from the right hand side, correct, or you can start from the bottom. So or like 1, 2, 3 like this, like from bottom, right side or left side. Anyway, like you chose any three carbon as a main parent, as the carbons of the main parent chain, the name will be exactly same. We start the numbering from anywhere in this structure. So let's go straight. 1, 2 and 3. Now I've numbered these three carbon, but this carbon is not numbered. That means this is acting as a branch to the main parent chain. Now there is a rule when we are writing between numbers, comma will come, and between alphabet and number. The number that we call is something called as locant position, is basically the carbon position of the main parent chain to which some branch is attached, or it can be a function group also, or any kind of substituent. So between alphabet and number, this hyphen will come. That's one of the rules. So how do we start the name for this? So if we talk about, let's say at second carbon of the main parent chain, our main parent chain is having three carbon atom. That means the word root is going to be prop. So at second carbon, if this carbon, we have a branch that is having only one carbon, that means we are going to call it as methyl. So we'll start the name like this. At second locant position, locant is that carbon of the main parent chain where any alkyl group is attached. So 2, then between alphabet and number hyphen will come, 2 methyl. Then this is our prefix. So word root is what? 3 carbon in the main parent chain. This is going to be prop. All single bonds, ane. We don't have a functional group. So 2 methyl over here is acting as a prefix. To be more precise, this is secondary prefix. We don't have primary prefix over here, so we skip that. Prop over here is our word root, and ane stands for which kind of suffix? That is primary suffix, to be more precise. We don't have secondary suffix over here. So this kind of questions can come, like at least identify the, you can say like IUPAC, write the correct IUPAC name of different organic compounds, or they can ask you that what is the prefix in this organic compound, what is the word root, what is the primary suffix, secondary suffix. These kind of questions they can ask. So that is all for today. Thank you.